On a clear night, the universe can seem surprisingly familiar. Thousands of stars stretch across the sky, each one appearing as a tiny point of light against an ocean of darkness. For thousands of years, people have looked upward and wondered the same thing. Is someone else out there? Somewhere beyond those distant suns, could another civilization be looking back toward us and asking exactly the same question? Today, we know far more about the universe than any generation before us. Powerful telescopes have revealed that our Sun is only one ordinary star among hundreds of billions inside the Milky Way. Beyond our galaxy lie hundreds of billions more galaxies, each filled with their own stars, planets, and countless possibilities. The numbers become so enormous that they almost lose their meaning. There are likely more planets in the observable universe than grains of sand on every beach on Earth combined. With numbers like these, the conclusion seems almost unavoidable. Surely life cannot be unique to our tiny world. Somewhere, another planet must have developed oceans, continents, and skies beneath a different sun. Somewhere, chemistry must have become biology, biology must have become intelligence, and intelligence must have looked toward the stars. Yet despite everything we've discovered, one fact has remained stubbornly unchanged. The universe has never answered. For decades, astronomers have scanned the skies with increasingly sophisticated instruments. Giant radio telescopes have listened for signals from nearby stars. Space telescopes have searched the atmospheres of distant planets for the chemical fingerprints of life. New observatories continue to discover thousands of worlds that could, at least in principle, support liquid water and perhaps even living organisms. Every year our knowledge grows. But the silence remains. Not a single confirmed message. Not a single verified spacecraft. Not a single unmistakable sign that another technological civilization has ever reached across the darkness. At first, this silence seems almost impossible to understand. If intelligent life is even moderately common, then the universe should be filled with civilizations, separated by millions or even billions of years of history. Some would be younger than us. Others would have had thousands, perhaps millions, of years to develop technologies beyond anything we can imagine. In a universe nearly 14 billion years old, humanity is a very recent arrival. If another civilization had begun exploring the stars a million years before we evolved, what traces might they have left behind? If they had mastered interstellar travel, could they have crossed the galaxy many times over? Would they have built enormous structures around stars? Filled space with communication networks? Sent robotic explorers drifting from one solar system to another? If such civilizations were common, it seems reasonable to expect that the evidence would be impossible to miss. Yet the sky appears almost perfectly quiet. For many people, this mystery is simply known as the search for extraterrestrial life. But there may be a deeper question hiding beneath it. Perhaps the problem is not that life is rare. Perhaps the universe itself makes contact extraordinarily difficult. Imagine two people standing on opposite sides of an enormous mountain range. Neither can see the other. They may shout with all their strength, believing the valley is empty because no reply ever comes. In reality, both are speaking into the same world. They simply occupy places that cannot easily communicate. Now imagine replacing the mountains with thousands of light years of empty space. Replace minutes with millions of years. Replace ordinary voices with signals that slowly fade as they cross the galaxy. The challenge begins to look very different. Throughout history, humanity has steadily erased the distances that once separated us. Oceans that required months to cross can now be flown in hours. Messages that once traveled by horseback now circle the planet in fractions of a second. Every generation has watched technology make the world smaller. It is natural to assume that the universe will eventually follow the same pattern. But space is not another ocean. The cosmos does not behave like our planet. The farther we explore, the more we discover that the universe obeys rules that are completely indifferent to our ambitions. Some of these rules are so fundamental that they shape everything from the birth of stars to the motion of galaxies. They cannot be negotiated, engineered around, or ignored. They define what is possible, and what is forever beyond reach. This documentary is not about whether aliens exist. No one knows the answer to that question. Instead, it explores something even more fascinating. Suppose the universe is filled with civilizations. Suppose intelligent life has emerged millions of times across cosmic history. Would they ever be able to find one another? Or would every civilization spend its entire existence believing it was alone? Over the next journey, we'll travel from our own solar system to the largest structures in the observable universe. We'll discover how the speed of light quietly limits every conversation that could ever take place between the stars. We'll see how galaxies themselves become natural barriers, how time separates civilizations even more effectively than distance, and why the expansion of the universe slowly carries entire regions of reality beyond each other's reach forever. We'll also explore one of the most humbling possibilities in modern science. The silence surrounding us may not be evidence of emptiness. It may simply be the natural consequence of living inside a universe built on extraordinary scales. Because the universe does not need to hide other civilizations from us. It only needs to be unimaginably large. As we begin this journey, it's worth remembering just how little of the cosmos humanity has actually explored. Every spacecraft we've ever launched remains within a tiny corner of our own solar system. Every radio transmission we've intentionally sent into space has traveled only a minute fraction of the distance across our galaxy. Even our most distant robotic explorers have barely stepped beyond our cosmic front yard. We often imagine ourselves standing at the edge of discovery. In reality, we've only just opened the front door. The greatest obstacle may not be our technology. It may be the universe itself. And before we can understand why other civilizations remain hidden, we first have to understand the extraordinary scale of the stage on which they would have to find one another. Because once you truly grasp the size of the cosmos, the silence begins to feel less mysterious. And far more inevitable. If you wanted to visit every country on Earth, it would take years. Even traveling by airplane, crossing oceans and continents becomes a journey measured in hours or days. On the scale of our planet, those distances feel enormous. They shape cultures, history, and the way we experience the world. Now imagine shrinking the Earth until it becomes no larger than a marble sitting in the palm of your hand. At that scale, the entire history of humanity, every mountain, every ocean, every city ever built would exist on something you could carry in your pocket. It feels small. Yet the moment you step beyond that marble, your intuition begins to fail. The moon, our closest celestial neighbor, is often shown in illustrations floating comfortably beside the Earth. The reality is very different. If the Earth were that marble, the moon would be another tiny marble positioned nearly 8 meters away. Between them would be almost nothing at all. Mostly empty space. That emptiness is the first thing the universe teaches us. Space is not crowded. It is astonishingly empty. Now imagine placing the sun into this same model. Instead of a blazing star filling the sky, it becomes a sphere about the size of a large beach ball. But that beach ball wouldn't sit in your backyard. It would stand almost 1 kilometer away from your tiny marble Earth. Between the two lies almost nothing. No glowing clouds. No rivers of energy. Just an enormous volume of near-perfect vacuum. Every planet in our solar system shares this emptiness. They orbit the Sun not because space is full, but because it is almost completely empty. Distances that appear close in textbooks are separated by millions, sometimes billions, of kilometers. Even light, the fastest thing the universe allows, needs time to cross these distances. Sunlight takes just over 8 minutes to reach Earth. When you watch a sunrise, you're seeing the Sun as it existed 8 minutes ago. If the Sun was somehow to disappear, Earth would continue orbiting an empty point in space for those same 8 minutes before anything changed. Light itself cannot move any faster. That single fact quietly shapes everything that follows. As enormous as our solar system seems, it represents only the smallest neighborhood of the galaxy. Beyond Neptune lies a vast region filled with icy bodies and distant comets. Far beyond that stretches another enormous cloud of frozen objects known as the Oort cloud, extending perhaps a light-year from the Sun. Even here, at the very edge of our solar system's gravitational influence, we have not yet reached another star. The nearest star is still more than 4 light-years away. 4 years. Not for a spacecraft. Not for an airplane. For light itself. Imagine turning on a flashlight tonight, and knowing that its beam would not arrive at the nearest star until more than 4 years from now. Every message humanity has ever transmitted into space is making that same slow journey. If another civilization happened to live on a planet orbiting our nearest neighboring star, and if they possessed a telescope capable of detecting our first radio broadcasts, they would only now be beginning to receive television signals from the early 20th century. If they replied immediately, their answer would not return to Earth for another 4 years. A simple greeting would require more than 8 years. And that is the absolute best-case scenario. Most stars are much farther away. Some lie hundreds of light-years from Earth. Others are thousands. The Milky Way itself stretches roughly 100,000 light-years across. If you could somehow travel at the speed of light, the fastest speed permitted by physics, crossing our galaxy would still require 100,000 years. Human civilization has existed for only a tiny fraction of that time. Entire empires have risen and disappeared in less than 1% of a single light-year crossing. Now consider our place inside this enormous structure. The Milky Way contains hundreds of billions of stars. Our Sun resides quietly within one of its spiral arms, orbiting the galactic center at a distance of about 26,000 light-years. Completing a single orbit around the galaxy takes approximately 230 million years. The last time Earth occupied this position in its orbit around the Milky Way, dinosaurs still dominated the planet. Galaxies move on timescales so immense that human history becomes almost invisible. Even if another civilization lived somewhere else in the Milky Way, the chances of them existing close enough for meaningful communication are already incredibly small. Distance alone stretches every possible conversation across centuries, millennia, or longer. And then there is everything beyond our galaxy. The nearest major galaxy, Andromeda, appears in our night sky as a faint smudge barely visible without optical aid. To the naked eye, it seems almost close enough to touch. It is anything but close. Its light has traveled approximately 2.5 million years before reaching Earth. When that light began its journey, our earliest human ancestors had not yet evolved. Everything happening inside Andromeda today remains hidden from us. We will not witness its present until light from that present arrives millions of years in the future. In a very real sense, astronomy is a form of time travel. Every telescope is also a machine for looking into the past. The farther we look into space, the further back in time we see. Some of the galaxies photographed by modern observatories appear exactly as they existed more than 13 billion years ago, when the universe itself was still young. We never observe the universe as it is. We observe it as it was. That distinction becomes profoundly important when thinking about other civilizations. Suppose a civilization existed in a galaxy 50 million light-years away. If they transmitted a message toward Earth today, we would not receive it for another 50 million years. By then, continents will have shifted. Species will have evolved or vanished. Humanity itself may no longer exist. The universe permits communication. But it separates cause and effect by intervals so vast that conversation becomes almost meaningless. This is where our everyday intuition begins to collapse completely. On Earth, distance is usually an inconvenience. Across the universe, distance becomes destiny. Every civilization is born inside its own tiny island of stars, surrounded by oceans of emptiness that can never be crossed quickly. Every attempt to explore beyond that island must obey the same physical laws. No matter how advanced a civilization becomes, no matter how intelligent its scientists or how powerful its machines, the universe imposes the same speed limit on everyone. No shortcuts have ever been observed. No exceptions have ever been confirmed. Every photon, every spacecraft, every piece of information must undertake the same unimaginably long journey through nearly empty space. And yet, despite these staggering distances, space itself is not the greatest barrier between civilizations. In many ways, it is only the beginning. Because even if two civilizations somehow overcome the impossible distances separating their worlds, another obstacle quietly waits beyond them. An obstacle that may be even more difficult to overcome than space itself. Time. If space were the only obstacle between civilizations, the universe would already be difficult enough to explore. Distances measured in light-years ensure that every journey is long, every message is delayed, and every attempt at communication demands extraordinary patience. But there is another barrier that is even less intuitive. Unlike distance, it cannot be measured with a ruler or crossed with a faster spacecraft. It is time itself. When we imagine another civilization somewhere in the galaxy, we naturally picture them existing right now. We imagine another planet beneath another sun, where cities are lit, telescopes are pointed toward the sky, and curious minds are asking the same questions we are asking today. But the universe offers no reason to believe that civilizations appear at the same moment. In fact, the opposite is almost certainly true. The universe is approximately 13.8 billion years old. Earth formed around 4.5 billion years ago, and for most of that history, our planet was inhabited only by microscopic life. Complex organisms appeared much later. Dinosaurs dominated the Earth for more than 160 million years, and modern humans have existed for only a few 100,000 years. Our technological civilization is younger still. Radio communication has existed for little more than a century. Spaceflight began only a few generations ago. On the scale of cosmic history, humanity has occupied its technological phase for the briefest imaginable moment. Imagine compressing the entire age of the universe into a single calendar year. The Milky Way forms in the early months. The Sun and Earth appear in September. Complex life arrives only in December. Dinosaurs disappear on the evening of December 30th. Modern humans emerge just before midnight on December 31st. Everything we call recorded history occupies only the final few seconds before the new year begins. Our entire age of science, electricity, radio, computers and spacecraft would exist in less than the blink of an eye. If another civilization followed a similar path but appeared only a few million years earlier, they would already have passed through stages of history we cannot begin to imagine. Their greatest achievements might already belong to a distant past before humanity even existed. Likewise, another civilization could arise millions of years after we are gone, studying the same stars and wondering whether they are the first intelligent beings to inhabit the galaxy. Both civilizations would exist. Neither would ever know the other. This is one of the quietest consequences of cosmic time. Existence alone is not enough. Civilizations must overlap. Imagine thousands of candles being lit at random moments throughout a long winter night. Some burn brightly for only a few minutes. Others last an hour before disappearing. If you happen to light your candle long after another has gone out, you will never know it illuminated the room before you arrived. From your perspective, the darkness is complete. The universe may work in much the same way. Every civilization could be its own candle, burning for a relatively short period against billions of years of cosmic history. Some may endure for thousands of years. Others perhaps millions. But compared to the age of the galaxy, even a million years is astonishingly brief. The Milky Way has existed for more than 13 billion years. A civilization lasting 1 million years would occupy less than 1/10,000th of that history. If intelligent societies arise only occasionally, the probability that two nearby civilizations exist during exactly the same period may be far smaller than we instinctively expect. The universe does not coordinate beginnings. Stars form independently. Planets cool independently. Life evolves independently. Every world follows its own timeline. Some stars are billions of years older than our Sun. Others were born only recently. Around each one, planets experience different climates, different chemistry, different rates of evolution. A small difference early in a planet's history can become a difference of hundreds of millions of years later. No cosmic clock synchronizes these worlds. Each one keeps its own time. Even if life is abundant throughout the galaxy, intelligent civilizations may simply be scattered across different eras. One civilization might send its first radio transmission while another has already vanished into history. Another may not evolve until long after ours has disappeared. The tragedy is not that they failed to communicate. It is that they never had the opportunity. And there is another consequence that is even stranger. Every observation we make of the universe is already delayed by the finite speed of light. When astronomers detect a distant planet hundreds of light years away, they are not seeing it today. They are seeing it centuries ago. If an intelligent civilization lived there, we have no way of knowing whether it still exists. Perhaps it is thriving. Perhaps it disappeared generations before the light ever reached us. The same uncertainty applies in the opposite direction. Any civilization observing Earth from hundreds of light years away would not see modern humanity. They would see our planet before airplanes, before electricity, perhaps even before written language. To them, our greatest achievements have not yet happened. Time quietly separates observers from the realities they hope to understand. The farther apart two civilizations become, the more history stands between them. Distance delays information. Time transforms it. This means that even perfect communication cannot erase the past. Every message becomes a historical document by the moment it arrives. Imagine receiving a letter written during the construction of the Great Pyramid. Remarkable though it would be, it could never become a conversation. The people who wrote it would have been gone for thousands of years. On cosmic scales, every message risks becoming exactly that. An artifact from a civilization that no longer exists. For beings separated by hundreds or thousands of light years, dialogue slowly turns into archaeology. We stop speaking with each other. We begin excavating each other's past. And yet, astonishingly, time itself is still not the greatest limitation imposed by the universe. Because beneath every delay, beneath every distance and every century of waiting, lies an even more fundamental law. A law that governs every beam of light, every radio transmission, every spacecraft ever launched, and every particle moving through space. It is a limit that no civilization has ever overcome. And it begins with the fastest thing the universe allows. Imagine standing on a distant planet beneath an unfamiliar sky. You build the most powerful transmitter your civilization has ever created. You gather the energy of an entire world, focus it into a narrow beam, and send a message toward another star. The signal leaves your planet. It races across the darkness at the fastest speed the universe permits. Nothing can overtake it. Nothing can carry information any faster. And yet, despite traveling at the ultimate speed allowed by nature, years pass before it reaches the nearest star. The universe is not slow because light moves slowly. The universe feels slow because it is unimaginably large. Light travels almost 300,000 kilometers every second. In a single heartbeat, it circles Earth more than 7 times. It reaches the Moon in just over 1 second. It crosses the distance between Earth and the Sun in a little more than 8 minutes. For anything within our daily experience, light is effectively instantaneous. Flip a light switch, and the room brightens immediately. Look toward the mountains, and the delay is too small to notice. Our lives unfold on scales where light appears infinitely fast. The illusion disappears the moment we leave Earth behind. The nearest star lies more than 4 light-years away. Even light must spend over 4 years making the journey. A spacecraft traveling at only a fraction of light speed would require decades. At the speeds of today's fastest spacecraft, the trip would last tens of thousands of years. The universe has quietly imposed a speed limit that no experiment has ever broken. For more than a century, scientists have tested this limit with extraordinary precision. Every experiment, every particle accelerator, every observation of distant galaxies has reinforced the same conclusion. Nothing carrying information travels faster than light. This is not merely a technological challenge. It appears to be woven into the structure of reality itself. As an object moves faster, accelerating it becomes increasingly difficult. Each additional increase in speed demands more energy than the last. Near the speed of light, the required energy grows so dramatically that reaching light speed would require an infinite amount of energy. The universe contains no infinite energy. Which means the speed of light is not simply difficult to achieve. It is a boundary. Every civilization, no matter how advanced, must live inside it. Perhaps one day we will develop engines capable of reaching 10% of light speed. Perhaps 20. Even 50. Such achievements would transform humanity forever. Yet even then, nearby stars would remain years away. Crossing the Milky Way would still require longer than the entire span of recorded human civilization. The speed limit does more than restrict travel. It governs information itself. Every observation depends upon light. Every telescope collects ancient photons. Every image from a distant galaxy is already history by the time it reaches us. We never experience the universe as it exists at this instant. We experience delayed versions of reality. This means no civilization can ever possess a complete picture of the cosmos. Everyone lives inside their own expanding bubble of knowledge. Beyond that bubble, events continue unfolding unseen. Imagine standing in the middle of a vast forest during a heavy snowfall. Your lantern illuminates only the trees immediately around you. Beyond its light, the forest still exists, but you cannot know what is happening there until information slowly reaches you. The observable universe functions in much the same way. Light continuously expands our awareness. But it never allows us to see everything. Every civilization lives inside its own horizon of knowledge. Beyond that horizon lie events that are, for the moment, unknowable. And for some parts of the universe, unknowable forever. This realization changes the way we think about exploration. It is tempting to imagine that future technology will eventually erase every limitation. History encourages that optimism. We crossed oceans once believed impassable. We flew through skies once reserved for birds. We walked upon another world. Again and again, humanity has overcome barriers that once seemed permanent. But not every barrier is technological. Some are physical. The speed of light belongs to the second category. It is not a challenge waiting for a clever engineer. It is one of the rules that defines the universe itself. That single rule shapes every possible future for intelligent life. It determines how civilizations explore, how they communicate, how they observe the cosmos, and perhaps whether they ever meet at all. Yet even this fundamental limit is only one piece of a much larger puzzle. Because while light struggles across space, something else is happening to the universe itself. The distance between galaxies is not remaining constant. It is growing. And that simple fact may be the greatest obstacle of all. When we picture the universe, we often imagine something permanent. The stars appear fixed in the night sky. The constellations seem unchanged from one generation to the next. Even the Milky Way stretches overhead with the quiet confidence of something eternal. But this stillness is an illusion. Nothing in the universe is truly standing still. Every star is moving through the galaxy. Every galaxy is traveling through space. Entire clusters of galaxies drift together over hundreds of millions of years, while the universe itself continues to expand in every direction. The cosmos is not a frozen landscape. It is a constantly changing ocean. For most of human history, we assumed the universe was static. It seemed reasonable. After all, the stars looked no different from one century to the next. Without powerful telescopes, there was little reason to think otherwise. That changed in the early 20th century. Astronomers studying distant galaxies noticed something remarkable. Almost every galaxy appeared to be moving away from us. More surprising still, the farther away a galaxy was, the faster it seemed to be receding. At first glance, this sounds as though Earth occupies the center of the universe. It does not. If observers lived in another galaxy billions of light years away, they would see exactly the same pattern. Every distant galaxy would appear to be moving away from them as well. The reason is surprisingly simple. Galaxies are not flying through space like debris from an explosion. Instead, space itself is expanding. Imagine drawing small dots across the surface of an uninflated balloon. As the balloon inflates, every dot moves farther away from every other dot. None of the dots are actively crawling across the rubber. The surface itself is stretching. Our universe behaves in a remarkably similar way. The fabric of space gradually expands, increasing the distance between galaxies without requiring them to travel through space at extraordinary speeds. For nearby galaxies, gravity is strong enough to resist this expansion. Our neighboring Andromeda galaxy, for example, is actually moving toward the Milky Way. Billions of years from now, the two galaxies will slowly merge into a much larger system. But beyond our local neighborhood, expansion dominates. The farther a galaxy lies from us, the more rapidly space grows between us. At unimaginably large distances, something extraordinary happens. The expansion becomes so great that even light cannot overcome it. This sounds impossible at first. How can anything move away faster than the speed of light if nothing is allowed to travel faster than light? The answer lies in understanding what is actually moving. Galaxies are not outrunning light through space. Space itself is growing. Imagine walking along an airport moving walkway that is carrying you backward faster than you can walk forward. No matter how quickly you move, the floor beneath your feet continues pulling you away. That is what the expanding universe does on its largest scales. Light keeps traveling exactly as physics requires. Yet the distance it must cross grows at the same time. For sufficiently distant galaxies, the gap increases faster than light can close it. Those regions become permanently unreachable. Not because we lack better rockets. Not because our technology is primitive. Because reality itself prevents the journey. There exists a cosmic horizon beyond which no signal sent today can ever reach us. Likewise, no message from beyond that horizon can ever arrive here. Those civilizations, if they exist, are forever separated from us. Not by choice. Not by war. Not by distance alone. By the structure of space-time itself. This realization changes the way we think about the observable universe. Everything we can see, the hundreds of billions of galaxies revealed by our telescopes, represents only the portion of reality from which light has had enough time to reach us since the universe began. Beyond that lies more universe. Perhaps much more. Possibly infinitely more. Yet no telescope will ever reveal it. Not because it is hidden. Because its light can never arrive. Our observable universe is not the entire universe. It is simply the part forever connected to us by the speed of light, and the age of the cosmos. Every civilization possesses its own observable universe. Most of those observable universes overlap only partially. Others never overlap at all. Entire galaxies may exist that will forever remain beyond our awareness. Entire civilizations may spend billions of years wondering whether they are alone, never realizing that countless others exist just beyond horizons that no signal can cross. Isolation is built into the geometry of reality. Even if intelligent life fills the universe, every civilization inhabits only a tiny island of knowledge surrounded by an ocean that can never be explored completely. As the universe continues expanding, these islands slowly drift farther apart. In the unimaginably distant future, galaxies outside our local group will disappear from view entirely. Future astronomers living trillions of years from now may never know that other galaxies ever existed. Their skies will appear almost empty, leaving them to conclude that the universe contains only their own island of stars. Ironically, they would be wrong. The universe would still be full of galaxies. They would simply be forever unreachable. The universe does not merely separate civilizations. Given enough time, it separates entire galaxies. And as remarkable as this expansion is, it still assumes that civilizations survive long enough to experience it. The truth is that the universe presents another challenge long before expansion ever becomes important. A challenge that has shaped life on Earth from the very beginning. Because the cosmos is not simply vast. It is also remarkably dangerous. When we look at the night sky, it is easy to imagine the universe as peaceful. Stars sparkle quietly above us. Galaxies drift gracefully through the darkness. Everything appears calm. Yet behind that beauty lies an astonishing level of violence. The universe is one of the most energetic places imaginable. Stars are born in enormous clouds of gas that collapse under gravity until nuclear fusion ignites within their cores. For millions or billions of years they shine steadily, producing the light and warmth that make planets like Earth possible. Eventually, many of those stars die. Some fade quietly. Others explode with unimaginable force. A single supernova briefly outshines an entire galaxy. For a few weeks, one dying star can radiate more energy than our Sun will produce during its entire lifetime. These explosions scatter heavy elements across space, creating the carbon, oxygen, silicon, and iron that later become planets, and eventually living organisms. In many ways, every atom in our bodies owes its existence to ancient stars that died long before the sun was born. Life depends on stellar death. Yet those same explosions can also destroy life. If a sufficiently massive star exploded close to Earth, intense radiation could strip away much of our atmosphere's protective ozone layer. Ultraviolet radiation from the sun would then flood the surface, dramatically altering ecosystems around the globe. Fortunately, no nearby stars currently pose such a threat. But not every region of the galaxy is so fortunate. Near the center of the Milky Way, stars are packed much closer together. Massive stars form more frequently, explode more often, and fill surrounding space with intense radiation. Life may struggle to survive there for billions of years uninterrupted. Distance from danger matters. Our solar system occupies a relatively quiet neighborhood at 26,000 light-years from the galactic center. Close enough to contain the heavy elements needed for rocky planets. Far enough to avoid many of the galaxy's most hazardous environments. Astronomers sometimes describe this region as part of the galactic habitable zone. Not because it guarantees life, but because it offers stability. And stability may be the rarest ingredient of all. Life does not emerge overnight. On Earth, simple organisms appeared remarkably early. Yet complex multicellular life required billions of years to evolve. During those billions of years, our planet experienced asteroid impacts, ice ages, volcanic eruptions, shifting continents, changing oceans, and multiple mass extinctions. Again and again, evolution was interrupted. Again and again, life began rebuilding. Perhaps the most famous interruption occurred about 66 million years ago. An asteroid roughly 10 kilometers across struck what is now Mexico, releasing more energy than billions of nuclear bombs. The impact darkened Earth's skies, disrupted global climates, and brought an end to the dinosaurs. For many species, it marked the end of an evolutionary journey that had lasted more than 160 million years. For mammals, however, it created an unexpected opportunity. Without that single impact, humanity might never have appeared. Chance has always played a remarkable role in Earth's history. Small changes early in a planet's development can produce entirely different futures. A slightly larger asteroid. A nearby supernova. A different arrangement of continents. A longer ice age. Each event nudges evolution in a new direction. Intelligence, it seems, is not inevitable. Even on Earth, technological intelligence evolved only once. For hundreds of millions of years, countless species flourished without building radios, telescopes, or spacecraft. Evolution rewards survival. It does not reward science. The human brain consumes an extraordinary amount of energy. Maintaining such a large and complex organ is biologically expensive. Intelligence must provide tremendous evolutionary advantages before natural selection favors it. Perhaps those advantages rarely appear. Perhaps most planets remain populated by organisms perfectly adapted to their environments without ever developing advanced technology. Some worlds may host oceans filled with complex life. Others may be covered by forests unlike anything on Earth. Still others may support intelligent creatures that communicate, cooperate, and solve problems, but never invent electricity. Technology is not the inevitable destination of evolution. It is only one possible path. This idea leads scientists to one of the most intriguing concepts in modern astronomy. The Great Filter. Somewhere between lifeless chemistry and galaxy-spanning civilizations may lie one or more steps, so improbable that almost no world ever completes them. Perhaps simple life is incredibly rare. Perhaps complex cells almost never evolve. Perhaps intelligence seldom appears. Or perhaps civilizations regularly destroy themselves before reaching the stars. At present, we simply do not know. Earth provides only one example of life. From a sample size of 1, it is extraordinarily difficult to estimate how common anything truly is. Imagine trying to determine how often trees grow by examining a single forest. You might conclude forests cover every continent. Or you might conclude yours is unique. Without additional examples, certainty remains impossible. The universe presents us with the same challenge. We know life happened once. We do not yet know how often it happens elsewhere. Every new exoplanet discovered by astronomers offers another possible home. Every atmospheric observation brings us closer to detecting signs of biology. Yet for now, the silence continues. Perhaps the greatest obstacle facing civilizations is not distance. Perhaps it is surviving long enough to wonder about the stars at all. Because before any civilization can explore the universe must first allow it to exist. If another civilization exists somewhere among the stars, how would we ever know? Most people imagine a message. Perhaps a radio transmission carrying mathematics, music, or a simple greeting. Maybe a laser pulse, sent deliberately across interstellar space. Or perhaps a signal so advanced that we wouldn't even recognize it as technology. For more than half a century, humanity has been listening. Powerful radio telescopes have scanned the skies searching for patterns that nature is unlikely to produce. Narrow radio frequencies. Repeating pulses. Artificial-looking signals that stand apart from the random noise of the universe. So far, nothing has been confirmed. This often surprises people. After all, we've been using radio technology for more than 100 years. Television broadcasts, military radar, satellite communications, and countless other transmissions have been leaking into space since the early 20th century. Shouldn't another civilization already know we're here? The answer is almost certainly no. Because radio signals do not travel through the universe the way they do in movies. Imagine dropping a pebble into a perfectly still lake. The ripples spread outward in every direction. At first they are strong and easy to see. But as they move farther from the point of impact, they become wider, weaker, and eventually disappear into the surface of the water. Radio waves behave in much the same way. Every transmission spreads over a larger and larger sphere as it moves through space. The total energy remains the same, but it is distributed across an ever-increasing area. The result is simple. Distance weakens everything. Double the distance, and the signal becomes 4 times weaker. Increase the distance tenfold, and it becomes 100 times weaker. Continue long enough, and even the strongest transmission fades into the natural background noise of the universe. This means that Earth's accidental radio leakage is far less impressive than we often imagine. Although our broadcasts have been traveling outward for roughly a century, they now occupy only a tiny bubble around our planet. Compared with the size of the Milky Way, that bubble is almost invisible. If the Milky Way were the size of North America, our radio broadcasts would have reached only a few city blocks. And even within that tiny region, the signals have become incredibly faint. A civilization dozens of light years away would need extraordinarily sensitive equipment, and would almost certainly have to be looking specifically at Earth to detect our earliest transmissions. Otherwise, they would simply disappear into the hiss of the cosmos. Perhaps every civilization faces the same problem. Perhaps millions of worlds have spent centuries broadcasting their existence, never realizing that their voices become whispers long before reaching another star. Even if signals survive the journey, another challenge immediately appears. Recognition. How do you recognize intelligence when you've never encountered it before? Humans naturally search for patterns that make sense to us. Prime numbers. Repeating mathematical sequences. Artificial pulses that seem unlikely to occur naturally. Mathematics appears universal. 2 plus 2 equals 4 everywhere in the universe. The geometry of a circle remains the same around every star. It seems reasonable to believe another civilization might use mathematics as a common language. But what if they don't? Imagine trying to communicate with an octopus using written English. The problem is not intelligence. Octopuses are remarkably intelligent creatures. The problem is that our minds evolved to understand the world differently. Now multiply that difference by millions of years of independent evolution on another planet. Another civilization may perceive reality through senses we do not possess. They may communicate through methods we have never imagined. They may organize knowledge in ways completely unlike our own. Their signals might wash across Earth continuously while appearing to us as meaningless background noise. Not because they are hiding. Because we have no idea what we are listening for. Nature makes this even more complicated. The radio sky is anything but silent. Pulsars rotate hundreds of times every second, sending rhythmic beams of radio waves across the galaxy. Supermassive black holes launch enormous jets of energetic particles. Nebulae glow in radio frequencies invisible to our eyes. Fast radio bursts appear suddenly, releasing extraordinary amounts of energy before vanishing again. The universe produces countless strange signals all by itself. Separating nature from technology is not always straightforward. Astronomers must carefully eliminate every natural explanation before considering an artificial one. The standard is intentionally demanding. Extraordinary claims require extraordinary evidence. One false alarm could mislead the entire scientific community. Over the decades, a handful of mysterious signals have captured worldwide attention. Each generated excitement. Each inspired speculation. Yet none has provided definitive evidence of another civilization. The silence has remained remarkably consistent. Still, that silence should not discourage us. In fact, it tells us something profound. It tells us how extraordinarily difficult communication truly is. Imagine standing on opposite sides of Earth, and attempting to hear someone whisper. No matter how carefully you listen, the whisper simply cannot survive the journey. Now replace Earth with 100,000 light years. Replace air with nearly perfect vacuum. Replace minutes with centuries. That is the challenge every civilization faces. Perhaps we are all speaking. Perhaps we are all listening. And perhaps the universe is simply too vast for our voices to carry. Yet there is another possibility. An even stranger one. Maybe advanced civilizations eventually stop broadcasting altogether. Not because they disappear, but because progress itself changes the way they communicate. Technology rarely stands still. Only a century ago, powerful radio towers filled the air with broadcasts traveling in every direction. They were inefficient by today's standards, wasting enormous amounts of energy simply because there was no better alternative. Today, much of our communication has become quieter. Fiber optic cables carry information without broadcasting it into space. Satellites direct signals precisely where they are needed. Wireless technologies continue becoming more efficient every year. Ironically, as our technology improves, Earth becomes less visible. The universe may reward efficiency. An advanced civilization would likely waste very little energy. Rather than transmitting enormous omnidirectional broadcasts, they might use tightly focused laser beams, quantum communication technologies yet to be discovered, or methods that produce almost no detectable leakage at all. From a distance, such a civilization could appear completely silent. Not because nothing is happening. Because everything is happening too efficiently to notice. Imagine looking toward a modern city from thousands of kilometers away. If every window were perfectly insulated and every streetlight directed downward, the city might become nearly invisible despite millions of people living inside it. Technology often hides itself. Perhaps civilizations become quieter as they become more advanced. If that is true, our search may be focused on exactly the wrong kind of evidence. We often assume advanced civilizations should be easier to detect. The opposite may be true. They may leave fewer signatures than civilizations only slightly more advanced than ourselves. This leads to another fascinating possibility. Instead of searching for messages, perhaps we should search for engineering. Imagine a civilization using the energy of its entire star. A star radiates an almost unimaginable amount of power every second. Capturing even a tiny fraction would revolutionize any civilization. Capturing all of it would require structures of extraordinary scale. One theoretical concept, often discussed by astronomers, is known as a Dyson sphere. Despite the name, it is probably not a solid shell surrounding a star. A more realistic version would consist of countless satellites, habitats, and solar collectors orbiting the star together, harvesting enormous amounts of energy. From far away, such a system might look unusual. The visible light from the star would appear dimmer. Meanwhile, excess heat from the enormous structures would radiate into space as infrared energy. Instead of listening for voices, we might search for footprints. Astronomers have already begun looking for unusual infrared signatures that could hint at immense artificial structures. None have been confirmed. But the search continues. Other possibilities are even more ambitious. Perhaps an advanced civilization constructs gigantic computers orbiting black holes. Perhaps they move planets into more favorable orbits. Perhaps they build artificial habitats far larger than any natural world. To us, these projects would appear almost miraculous. Yet they would still obey the laws of physics. Technology cannot eliminate those laws. It can only work within them. Another possibility is that civilizations deliberately choose not to announce themselves. There are practical reasons for such caution. Broadcasting enormous signals requires enormous energy. Listening requires comparatively little. Suppose every civilization reaches the same conclusion. Why waste precious resources shouting into a galaxy that appears empty? Better to remain quiet and listen. Now imagine millions of civilizations making exactly that calculation. Every world builds giant telescopes. Every world waits. Every world listens. Hardly anyone broadcasts. The galaxy becomes filled with listeners. But almost no one speaks. It resembles a room where every person expects someone else to begin the conversation. The silence is not created by emptiness. It is created by caution. Of course, there is another possibility. Perhaps many civilizations once broadcast proudly across the stars. Perhaps they filled their skies with powerful radio transmissions much as humanity once did. Then, as technology matured, they gradually transitioned toward quieter methods. Their noisy phase lasted only a few centuries. Compared to billions of years of galactic history, such a period is almost unimaginably brief. This introduces another hidden challenge. Timing. Suppose every civilization remains easily detectable for only 200 or 300 years before becoming technologically quiet. The probability that two civilizations overlap during those brief windows becomes surprisingly small. Even if intelligent life is widespread, civilizations may repeatedly miss one another. Not because they are separated by space, but because they are separated by technology itself. Humanity may currently occupy one of the loudest periods in its own history. Future generations may communicate almost entirely through systems that leak virtually nothing into space. If another civilization searched for Earth thousands of years from now, they might find our planet strangely quiet compared with today. Not because humanity vanished. Because we became harder to notice. This possibility encourages scientists to broaden the search. Instead of looking only for radio signals, astronomers now investigate what they call technosignatures. These include unusual atmospheric chemistry, artificial light on distant worlds, enormous energy consumption, industrial pollutants, megastructures, or other evidence that nature alone struggles to explain. The search is expanding. And it must. Because the universe has repeatedly taught us an important lesson. Reality is often stranger than our first assumptions. The first exoplanets surprised us. Black holes surprised us. Dark energy surprised us. Perhaps intelligent life will surprise us as well. Maybe we have been searching for conversations, when we should have been searching for civilizations. Yet even if we eventually discover unmistakable evidence that another civilization exists, one final question remains. Could we ever reach them? Or has the universe already made that impossible? That question takes us to one of the most humbling possibilities in all of cosmology. Perhaps every civilization is destined to spend eternity inside its own island of stars. Throughout history, humanity has transformed the impossible into the ordinary. There was a time when crossing an ocean required months of uncertainty. Entire civilizations lived and disappeared without ever knowing what existed beyond the horizon. Then came larger ships, steam engines, airplanes, and eventually spacecraft. Every generation expanded the boundaries of what seemed achievable. It is natural to believe that interstellar travel will simply follow the same pattern. Build a faster engine. Develop better materials. Wait long enough. Eventually, the stars become destinations. It is an inspiring vision. But the universe is not obligated to reward optimism. Every journey through history became easier because there was no fundamental law preventing it. Airplanes became possible because the laws of physics allowed them. Rockets reached space because gravity, while difficult to overcome, is not absolute. Interstellar travel is different. The greatest obstacle is not engineering. It is the enormous amount of energy required simply to approach the speed needed for meaningful travel. Imagine building the most advanced spacecraft humanity has ever conceived. It accelerates continuously for years, reaching 10% of the speed of light. At that speed, the journey to our nearest stellar neighbor would still require more than 40 years. That is only the travel time. It says nothing about slowing down, exploring a planetary system, or returning home. Increase the speed to 20% of light. The trip becomes roughly 20 years. At 50% of light speed, a level of engineering far beyond anything we currently understand, the journey still takes more than 8 years. These are extraordinary achievements. Yet they reach only the nearest star. The Milky Way contains hundreds of billions more. Suppose a civilization became capable of routinely traveling at half the speed of light. Crossing the galaxy would still require roughly 200,000 years for a round trip. By the time the explorers returned, Languages would have changed countless times. Civilizations would have risen and fallen. Entire species could have evolved. The travelers would be returning to a world almost completely unrecognizable. Time itself becomes part of every voyage. Some scientists have proposed generation ships. Rather than expecting one crew to survive the journey, enormous spacecraft could function as miniature worlds. Children would be born during the voyage, grow old aboard the ship, and eventually die before reaching the destination. Their descendants would continue the mission for dozens or even hundreds of generations. The people arriving would not be the people who departed. The ship itself would become a civilization. Others imagine suspended animation. If future medicine allowed humans to safely enter deep hibernation for decades or centuries, travelers might sleep through much of the journey. To them, only months might seem to pass. Outside the spacecraft, however, decades would still unfold. The universe continues keeping time. Then there are robotic explorers. Unlike humans, machines require no atmosphere, no food, and no biological lifespan. A sufficiently advanced civilization might send autonomous probes across interstellar space, allowing artificial intelligence to perform exploration long before living beings arrive. In many ways, this appears more practical. Machines tolerate radiation better. They require fewer resources. They can patiently travel for centuries if necessary. Some researchers have gone even further, proposing self-replicating probes. Imagine a robotic spacecraft arriving at a new planetary system. Instead of remaining alone, it uses local materials to build copies of itself. Those copies travel to neighboring stars and repeat the process. 1 becomes 2. 2 become 4. 4 become 8. Over millions of years, such probes could spread across an entire galaxy. At first, this idea sounds almost unbelievable. Yet mathematically, exponential growth is astonishingly powerful. Even if every journey required centuries, a self-replicating network could eventually visit enormous numbers of stars. If this is possible, where are they? This question has puzzled astronomers for decades. If technological civilizations are common and even one developed such probes millions of years before humanity appeared, traces of their exploration might already surround us. We have found none. Perhaps self-replicating probes are impossible. Perhaps civilizations choose not to build them. Perhaps they become too dangerous to release. Or perhaps the galaxy is simply far quieter than we imagine. Then there are the ideas that capture the public imagination most strongly. Warp drives. Wormholes. Hyperspace. Science fiction is filled with methods for outrunning light. Interestingly, modern physics does not completely dismiss every one of these ideas. General relativity allows mathematical solutions in which space-time itself bends in extraordinary ways. A wormhole, if it could exist and remain stable, might connect distant regions of the universe through a shortcut. Similarly, theoretical concepts like the Alcubierre warp drive suggest that instead of moving through space faster than light, a spacecraft might contract space ahead of itself while expanding space behind it. In principle, the spacecraft never breaks the cosmic speed limit because it remains stationary inside its own local region of spacetime. Space itself performs the movement. These ideas are fascinating. They are also deeply speculative. Every known version requires forms of matter or energy that have never been observed in the quantities required. Some violate conditions that appear fundamental to our current understanding of physics. Others demand negative energy densities unlike anything known to exist naturally. At present, they remain mathematical possibilities rather than engineering projects. Perhaps future discoveries will change that. Perhaps they will not. Science has repeatedly surprised us before. But until such breakthroughs occur, every civilization appears bound by the same universal rules. The stars are not forbidden. They are simply very far away. And perhaps that is enough. Yet there is another possibility that may be even more humbling. What if the civilizations we hope to meet are not separated from us by impossible distances, but by impossible ages? Whenever we imagine another civilization, we almost always imagine it existing today. Somewhere, at this very moment, another species might be gazing toward the stars. Perhaps they are building telescopes. Perhaps they are launching their first spacecraft. Perhaps they are wondering whether they are alone. It is an understandable assumption. After all, we experience the universe only in the present. But the universe does not organize itself around the present. It unfolds across billions of years. This raises an extraordinary possibility. Perhaps we are simply early. Our Sun belongs to a class of stars remarkably well suited for life. It is stable, long-lived, and provides a consistent source of energy that has allowed life on Earth to evolve over billions of years. Yet stars like our Sun are not the most common stars in the galaxy. By far the most numerous are red dwarfs. Small, cool, remarkably efficient. Some red dwarf stars may continue shining for hundreds of billions, or even trillions of years. That is difficult to comprehend. The universe itself is only about 13.8 billion years old. Many red dwarfs have barely begun their lives. If planets orbiting these stars can support life, then the overwhelming majority of habitable time in the universe still lies ahead. Humanity may have appeared astonishingly early. Imagine visiting a vast theater just moments after the doors open. The seats are almost empty. The lights remain bright. Very few people have arrived. From your perspective, it would be easy to conclude that almost no one intends to attend. Stay a few more hours. The theater becomes full. Perhaps our civilization occupies a similar moment in cosmic history. Not the closing act. The opening scene. Of course, life around red dwarf stars presents challenges. Their habitable zones lie much closer to the star than Earth's orbit lies to the Sun. Many planets in these regions become tidally locked. One side faces perpetual daylight. The other remains in endless night. Red dwarfs are also prone to violent stellar flares capable of stripping atmospheres from nearby planets. Whether such worlds can support long-term complex life remains an active area of scientific research. The answer is still unknown. Yet if even a small fraction prove habitable, the future of the universe could be extraordinary. Billions upon billions of years remain for new planets to cool. For chemistry to become biology. For biology to become intelligence. For intelligence to begin asking questions beneath unfamiliar skies. Humanity may not belong to the mature universe. We may belong to its youth. This idea changes the way we interpret the silence. Perhaps there is no mystery to solve. Perhaps the universe simply has not had enough time to produce most of its civilizations. Imagine planting an enormous forest. After only a few weeks, a handful of seedlings emerge from the soil. Looking across the field, you might think very little will ever grow there. Return centuries later. The landscape has become almost unrecognizable. The universe may be undergoing a similarly slow transformation. Stars continue forming. Planets continue appearing. Chemical complexity continues increasing. The greatest age of life may still lie far beyond anything humanity will ever witness. Ironically, if this idea is correct, future civilizations may inherit a richer cosmos than we do. Trillions of years from now, intelligent beings orbiting ancient red dwarfs could look back toward the earliest generations of stars and discover evidence that civilizations like ours appeared astonishingly early. To them, humanity might represent one of the universe's first experiments with intelligence. A civilization born before the cosmos reached its fullest potential. There is something profoundly humbling about that thought. For centuries we assumed ourselves latecomers. Modern astronomy increasingly suggests we may instead be among the earliest. If that is true, the silence surrounding us becomes far less surprising. The universe is not empty. It is simply unfinished. But whether we are early or late, whether civilizations are common or unimaginably rare, one question remains. If intelligent life truly fills the universe across space and time, what does that ultimately say about our own place within it? That answer may be the most remarkable of all. After everything we've explored, one possibility still remains. Perhaps the distances are simply too great. Perhaps time separates every civilization before they ever have the chance to meet. Perhaps intelligent life is extraordinarily rare. Or perhaps there is no one else. It is a possibility that many people instinctively reject. After all, the universe is unimaginably large. Hundreds of billions of galaxies. Trillions upon trillions of stars. More planets than anyone can reasonably comprehend. Surely somewhere, life must have emerged. Surely intelligence cannot belong to Earth alone. And perhaps it doesn't. But science asks us to separate what feels likely from what we actually know. At this moment, we have exactly one confirmed example of life anywhere in the universe. Our own planet. Every calculation about alien civilizations begins with that single data point. 1. Imagine trying to estimate how common mountains are after visiting only one planet. Perhaps every world has them. Perhaps almost none do. Without additional examples, certainty is impossible. Life presents exactly the same challenge. Earth tells us that life can exist. It does not tell us how often it exists. Some scientists believe simple life may emerge wherever conditions allow. Others argue that Earth's history contains so many unlikely events that repeating them elsewhere may be extraordinarily improbable. Consider everything that had to happen. The universe first needed to manufacture the elements required for chemistry. A stable star had to form. Rocky planets had to assemble. Liquid water had to remain on the surface for billions of years. The climate had to avoid permanent freezing and catastrophic overheating. Complex cells had to evolve. Multicellular organisms had to appear. Animals needed to survive repeated mass extinctions. One branch of mammals developed unusually large brains. Language emerged. Culture accumulated. Technology accelerated. At every stage, countless alternative outcomes were possible. Any one of those steps might be common, or astonishingly rare. We simply do not know. Sometimes people ask an interesting question. If intelligent life is so unlikely, why did it happen here? The answer lies in something known as the anthropic principle. It sounds complicated. The idea itself is surprisingly simple. We can only observe a universe compatible with our existence. Imagine buying a lottery ticket. The odds of winning are incredibly small. If you lose, you never have the opportunity to wonder what it feels like to win. Only the winner asks that question. Likewise, only a planet where intelligent observers eventually appear can ask why intelligence appeared at all. Our existence tells us that the improbable happened. It does not reveal how improbable it truly was. Perhaps Earth is one successful outcome among countless failures. Perhaps billions of lifeless planets surround us, each possessing almost, but not quite, the right ingredients. Or perhaps biology flourishes everywhere. Right now, both possibilities remain consistent with the evidence. If humanity really is alone, however, the implications become extraordinary. Every painting ever created, every symphony ever composed, every scientific discovery, every language, every memory, every dream, would represent the only known examples of those experiences anywhere in the observable universe. Every laugh ever shared, every act of kindness, every question ever asked beneath the night sky, everything our species has ever thought or imagined would be unique. Not unique because we are better. Unique because we happened. It is a strangely beautiful thought. Often, people assume that being alone would make humanity insignificant. Perhaps the opposite is true. If intelligence exists only here, then the universe has produced something unimaginably precious. Consciousness capable of understanding the stars. Matter capable of asking questions about itself. Tiny beings standing on a small planet, somehow learning to calculate the age of galaxies and measure the expansion of spacetime. That achievement is remarkable regardless of whether anyone else exists. Yet there is another perspective. Even if humanity is the only technological civilization today, that does not mean we will always be alone. One day, perhaps millions of years from now, another civilization may arise somewhere beneath another star. They may look upward just as we have. They may wonder if they are first, or if someone came before them. Perhaps they will discover traces of humanity. A faint atmospheric signature. An ancient spacecraft drifting silently between the stars. A radio signal stretched and weakened after millions of years of travel. Evidence that another civilization once wondered exactly what they are wondering now. If that day ever comes, the silence will finally be broken. Not because two civilizations spoke, but because one discovered that another had once existed. Even across millions of years. That connection would still matter. Because intelligence may be separated by space, separated by time, yet still united by curiosity. And curiosity has always been humanity's greatest strength. It brought us from caves to observatories, from stone tools to space telescopes, from wondering what the stars were, to understanding how they are born. Whether we are alone or not, the search itself has already transformed us. And perhaps that is the beginning of the answer. As we reach the end of this journey, it is worth returning to the question that began it all. Why does the universe seem so quiet? At first, the silence appears mysterious. A universe this vast should overflow with possibilities. Hundreds of billions of stars. Countless planets. Billions of years for life to emerge. Yet the night sky offers no obvious answers. But perhaps the silence was never the mystery. Perhaps the real mystery was our expectation that the universe should be easy to cross. Throughout this documentary, we have discovered that every layer of reality quietly separates civilizations. Space stretches across distances that challenge imagination. Time places millions of years between neighboring worlds. Light, despite being the fastest thing in existence, remains too slow for meaningful conversation across the galaxy. Signals weaken until they disappear into cosmic noise. Stars explode. Planets freeze. Civilizations may rise and vanish without ever knowing another existed. The universe does not need to hide anyone. Its own laws already accomplish that. Isolation is not an accident. It is the natural consequence of a cosmos built on extraordinary scales. And yet, despite every obstacle, despite every equation suggesting how difficult contact may be, humanity continues searching. We continue building larger telescopes. We continue discovering new planets. We continue listening to the sky. There is something deeply human about that refusal to stop asking questions. Curiosity has always carried us beyond the boundaries of our world. It pushed ancient sailors beyond familiar coastlines. It sent explorers across frozen continents. It launched spacecraft toward distant planets. And today, it drives us toward mysteries measured not in kilometers, but in light years. Perhaps one day we will discover unmistakable evidence of another civilization. Perhaps it will come as a faint atmospheric signature on a distant planet. Perhaps an unusual infrared glow surrounding a faraway star. Perhaps a radio signal unlike anything nature could produce. Or perhaps the first evidence will arrive in a form none of us have imagined. Science has surprised us many times before. It will almost certainly surprise us again. Or perhaps the universe will remain silent. Not for years. Not for centuries. But forever. If that happens, our search will still have been worthwhile. Because searching has taught us something extraordinary about ourselves. We have learned that a species occupying a tiny world around an ordinary star can understand black holes billions of light years away. We can measure the age of the universe, detect planets orbiting distant suns, observe galaxies whose light began traveling toward us before Earth existed. Few achievements in nature are more remarkable than that. We often describe ourselves as insignificant because of our size. Compared with galaxies, that is certainly true. Compared with the age of the universe, our lives are astonishingly brief. Yet significance is not measured by size. It is measured by understanding. The universe has existed for nearly 14 billion years. As far as we currently know, only one small corner of it has produced beings capable of wondering why it exists. Whether others share that ability remains unknown. But we do. And that alone is extraordinary. The stars above us are no longer distant lights. They are laboratories of physics. Nurseries of planets. Possible homes to futures we cannot yet imagine. Every point of light reminds us that the universe is larger than our fears. Larger than our ambitions. And larger than our certainty. Perhaps, somewhere tonight, beneath another sky, another civilization is asking the same question. Perhaps no one is. We simply do not know. The silence has not told us. Not yet. Until it does, we will continue to observe. We will continue to calculate. We will continue to imagine. And we will continue listening. Because every great discovery in human history began the same way. With someone willing to ask a question before the answer existed. The universe may be built to keep civilizations apart. But it also created something remarkable. It created minds determined to bridge impossible distances. And perhaps, that determination is the rarest thing the universe has ever produced. So the next time you step outside beneath a clear night sky, take a moment to look upward. The stars are still there. The silence is still there. But now you know that silence is not simply emptiness. It is distance. It is time. It is physics. It is the story of a universe so vast that even light struggles to cross it. And somewhere within that immense silence, on one small planet, orbiting one ordinary star. A civilization continues asking the oldest question ever spoken. Is anybody out there? For now, the universe remains silent. But humanity is still listening.